A chemical laboratory is a hazardous environment, due to the chemicals inside. Awareness of the hazards associated with chemicals, and knowledge about safety regulations and procedures is, therefore, an important requirement for operation inside a chemical laboratory. There are several hazards related to chemicals. To identify them quickly, the most common and relevant ones have been coded in hazard icons. The icon must be placed on any container of the chemical to alert any user of the most important hazards. Material hazards can be classified into two major categories, that is, 1. Risk of fire, and 2. Risk for the health. While the symbol on the hazard icons are mostly self-explaining, attention should be taken on the icons indicating flammable and oxidizing compounds. Both icons associate the material with fire hazards. However, a differentiation of the icons is essential, since flammable and oxidizing compounds are not compatible and, therefore, should be kept away from each other. The difference in the icons is the central ring resembling an O in the hazard icon for oxidizing material. Fire hazards are of highest priority for the laboratory safety, since a fire affects not only the people inside the respective lab, but the entire building. Fire inside a chemical laboratory typically originates from ignition of flammable vapor. Because of this, it is important to avoid vapor and electric sparks, which frequently serve as initiator for fire. Flammable vapor can be avoided by ventilation and proper closure of containers containing flammable liquids. This particularly applies for those liquids which exhibit low boiling points. Health hazards refer to different levels of toxicity. The systemic toxics immediately affecting life are characterized with a skull. Local acting chemicals are typically labeled as corrosive. The impact of a toxic depends on the route for the exposure. Attention should be particularly directed towards intoxication via inhalation and upon skin contact. Such chemical hazards associated require special precaution for safe operation inside the lab. Besides acute toxicity, chemicals can affect life and health of a person on a longer time scale. Of particular relevance are so-called CMR compounds, reflecting risk of cancer and infertility. Typically the risk is not associated with single short-time exposure, but develop over accumulated exposure even at low concentration. Chemicals, without sufficient evidence for toxic or CMR activity are labeled differently. While their hazard is considered lower, the classification may change upon evidence of toxic effects. Therefore chemicals labeled as with the hyphen shall be treated with equal respect to CMR and acute toxic chemicals. The primary targets for chemicals are the respiration system, the eyes as well as the skin, particularly at the arms. Highest priority for protection must be directed to the respiration system and the eyes, since chemical impact on these bears highest chance for severe and permanent damage. In order to avoid health effects due to chemical action on the body, personal protective equipment must be used. Essential and indispensable are eye protection, a lab coat and closed shoes, while protective gloves and respiration masks are optional. Their use, however, can become mandatory upon particular hazards in a chemical laboratory. Experience shows that particularly the impact of chemicals on the eyes is underestimated. The pictures show different stages for chemical actions on an eye. While the eye in the upper picture may recover upon treatment, permanent damage for the picture below is expected. The picture on the bottom finally is most likely associated with complete loss of sight. The treatment of eyes upon chemical exposure is difficult. Immediate rinsing is essential for any chance of repair, but reflex cause a person to close the eye to reduce its pain. Eye protection is most crucial inside a chemical laboratory, because of the short time window for first aid measures and the obstacles for an effective rinsing of eyes. While regulations worldwide are clear, their implementation is insufficient, as documented even in corporate videos. Different eye protection may apply inside a chemical laboratory. The lowest level of protection are safety glasses. Entering a chemical laboratory without safety glasses cannot be accepted at any time. The purpose of entering the lab is hereby entirely irrelevant. Safety glasses cannot be replaced with spectacles. The key feature of safety glasses is not, as widely assumed, the front window, but the side protection. The human eye is naturally protected by the eyelid, which closes automatically upon anything approaching. However, this protection scheme only applies for the front view, where the attention of the eye is directed to. A spill from the side will not be recognized and can, hence, easily enter the eye. The use of contact lenses inside a chemical laboratory is highly discouraged, because the lenses affect the efficiency of washing the eye in case of an accident. As a response to reduce the risk, the use of contact lenses inside the lab requires full-closed goggles to replace safety glasses, unless a full-face respiratory mask is worn. Protective gloves are optional, reflecting different needs of protection inside the chemical laboratory. The material for the glove must be chosen in response to recommendations in safety data sheets, since no glove can protect from all chemicals. It is also important to notice that no glove provides a permanent barrier against chemicals. Therefore, the glove should be removed directly after use. Gloves worn for a long time cause problems, because an exposure to the glove might not be noticed owing to the sweating inside the glove. The use of a lab coat is mandatory inside a chemical laboratory. The major protection function is the easy and safe removal of any upper lab clothing. A lab coat can be removed within a few seconds without exposing the eyes, since it does not have to be pulled over the head. Moreover, the material is selected from natural fiber, which reduces the hazard in case of fire. Natural fibers, particularly cotton, is not fireproof, but it burns only moderately and leaves a brittle ash network. This behavior substantially deviates from synthetic fibers, which catch fire more easily and typically melt upon fire exposure. The effect of the melting is a shrinking of the fabric and sticking on the body. Synthetic clothes are, therefore, difficult to remove in case of a fire, and enhances the chances for severe body damage. Therefore, synthetic clothes should be avoided inside a chemical laboratory. Particularly the use of head covers, scarves, based on synthetic fabrics is discouraged. A common misperception applies for protection mask. The use of surgical masks as protection against chemicals only applies for dust and droplets. While such masks may be useful for operation with fine powders and possibly nanomaterial, they do not provide any protection against toxic vapors or gas. A non-suitable mask effectively increases danger rather than reducing it, because it suggests a non-existing protection, which reduces the level of alertness. Closed shoes with strong stand support are required inside a chemical laboratory. The protection of the foot does not reflect higher health risk for the foot compared to the hand, for which gloves are optional personal protective equipment, but reflect the impact of chemical action on the foot for secondary accidents. A chemical spill affecting the foot can easily lead to uncontrolled movements, causing additional accidents by knocking over. Besides personal protective equipment, emergency infrastructure is another major aspect of safety inside a chemical laboratory. This involves fire extinguisher as well as emergency showers and eye wash stations. While the university is responsible for the provision of emergency infrastructure, it is the responsibility of every lab user to ensure that the emergency infrastructure is properly maintained and operational. Vapor hazards of chemicals are typically addressed with fume hoods, where developing vapors are removed by exhaust ventilation. Safe operations on fume hoods, however, require the window slash to be mostly closed. Moreover, the ventilation should not be compromised by unnecessary obstacles. Fume hoods, therefore, must not be used for storage and operation at the same time. Preparation for experiments inside a chemical laboratory involve not only the procedures, but also consideration of possible accidents and planning of a response for the latter. Most importantly, the hazard of the chemicals, which shall be used, need to be studied prior to any operation in the lab. Information can be obtained from so-called material safety data sheets. The documents provide information regarding potential hazards as well as instructions for safe operation and emergency response measures. MSDS, or SDS, of all chemicals inside a laboratory must be readily accessible. In case of any accident with chemical-based injuries, the MSDS needs to be provided to the medical doctor, to ensure a suitable treatment. MSDS are product-specific documents. This means that the hazard rating of products from different manufacturers can differ from each other. The reason can be impurities, which account for particular hazards. Because of this, the MSDS files for all products should be available at the lab. The supplier is required by law to provide the MSDS together with the chemical. Accident precaution covers several levels, which all depend on the person working in the chemical laboratory. Although the university takes responsibility for some of the action, it does not release everyone from sharing this responsibility. Working alone in a chemical laboratory is not allowed. The reason for this constraint is the requirement for someone else to provide first aid in case of an accident. The most illustrative examples of accidents, which require help, are a person on fire and a person with a chemical spill inside the eye. In both cases, the affected person is incapable for helping him, herself. Emergency contacts must be placed easily accessible inside a laboratory, typically near the telephone. In case of an accident, rational thinking is typically limited. Panic may affect the vision, so that allocation of essential safety infrastructure can become invisible. Because of this, it is important to familiarize with the lab and its infrastructure prior to any operation, so that there is no need to search, because you already know where to find everything. Common emergency scenarios in a chemical laboratory involve fire, spillage and injuries. Fire in a chemical laboratory should be addressed immediately, before the fire exceeds the size that can be handled by non-professionals. For any firefighting, however, the personal safety is of highest importance. In case of doubts, it is recommended to flight rather than to fight. However, in this case the alarm must be raised to ensure a proper evacuation and damage to others due to the fire. Please move to the assembly location for the respective building to avoid anyone taking a risk in order to save you, when you have already left. There are two types of fire extinguisher available for chemical laboratories. These refer to powder, ABC, and carbon dioxide. Both extinguisher target to block oxygen to reach the fire, thereby stopping it. While powder is safe for practically any fire, carbon dioxide is not compatible with burning metals and organometallic compounds. On the other hand, it avoids damage to electric devices and should, therefore, be used if the fire is suitable. However, in doubt, powder shall be the choice, since the damage by fire typically exceeds the damage of equipment by far. The proper use of a fire extinguisher is critical to avoid the spreading of fire. Never direct the fire extinguisher directly towards a burning liquid, instead over the liquid to block oxygen from the top. Splashing burning liquids are also the reason why water must not be used on burning liquids. A burning person must not be treated with a fire extinguisher, since the fire extinguisher, especially carbon dioxide, can kill the person. Chemical spills need to be contained immediately to avoid following incidents, like fire or intoxication of people inside the laboratory. For the containment of spills, special absorbers should be used. The type of the absorber depends on the spill. Injuries inside the chemical laboratory require frequently immediate first aid. However, after this fast response, a specialist shall be contacted rather than referring to self-medication. The safety data sheet for the chemical involved must be taken to the clinic to ensure proper treatment. Any medical treatment requires a subsequent filing of a report for the accident. Incident reports need to be filed. Accidents involving injuries, use of fire extinguishers and major spills need to be reported to the PTJ, while minor accident only need to be reported to the responsible person for the laboratory and recorded in an internal book. Chemicals have to be stored safely. The separation of incompatible chemicals is one essential requirement. Besides, certain chemicals may require locking owing to poison protection or other legal constraints. The amount of chemicals, especially flammable liquids, inside a laboratory should be limited to the typical use. The laboratory is not a storage place. Chemical incompatibility reflects chemicals which vigorously react with each other. The slide lists common incompatible chemical categories. Chemical storage must be separated from the location where chemicals are used. Suitable storage places involve refrigerators, ventilated cabinets for flammable liquids and specialized cabinets for corrosives. Most importantly, however, chemicals, particularly liquids, shall not be stored on shelves that enable absorption, for example wood. Moreover, secondary containment shall be practiced for larger containers to prevent damage and harm due to broken chemical containers. Expired chemicals may still be used, if it is safe. However, expired chemicals must be stored away from other chemicals and their continuous use requires a justification. Gas cylinders must be mounted at the wall to avoid falling. Transport of gas cylinders must be constrained without mounted valve. If a gas cylinder falls on the valve, it reacts like a rocket and is likely to pass several walls before it finally stops. Transport of chemicals require the use of carriers with secondary containments. While chemicals may be combined for transport, separate carriers have to be used for incompatible chemicals. Chemical waste must be stored in designated areas away from other chemicals. Containers have to be labeled according to the waste category immediately, and the date for the first waste collection has to be recorded on the container. The container must subsequently be disposed within a period of maximum 6 months. Containers must not be filled completely with waste to avoid breaking upon warming. A 2-3 finger height reserved for air must remain. In order to ensure safe operations inside chemical laboratories, the listed entries are forbidden. If you have further questions, please refer to the University's Laboratory Safety Handbook. Remaining questions should be addressed to the Safety Committee of the PTJ or OSH. Questions regarding scheduled waste shall be directed to JPPHB.